to the data cube computation. So to define the star schema, we are first defining the fact table, that is the cells fact table, by using define cube. So first we are given the name cell star and then we have listed all the dimensions जो भी cells table को connected है. Then we have listed all its measures. Next we have to define the dimension. So define dimension time as first the primary key of time dimension and day of week, month, quarter, year. So we'll define all the attributes, list of all attributes. Similarly, we'll define the item. Define dimension item as it's a primary key, item key, name, brand, type, supplier type. Likewise, we'll define the dimension branch and location. Got it? तो ब्रांच की प्राइमरी की डालेंगे, उसकी की डालेंगे, की एट्रीब्यूट एंड इट्स एट्रीब्यूट्स ब्रांच नेम एंड टाइप. Same for the location. We have location key and the other attributes of location dimension. We are defining this particular schema that is given example. So likewise you can have any database example and you can define the cube computation on it. तो सेम वे से हमें snowflake schema डिजाइन करना है. So for designing the snowflake schema, again we have one fact table. डिफरेंस क्या है यहाँ पे? सेम डिफाइन करेंगे जो अभी हमने किया है. इसको 4 डायमेंशंस कनेक्टेड है. टाइम एंड ब्रांच में कुछ डिफरेंस नहीं है. वी हैव द सेम डेफिनेशंस फॉर दिस ब्रांच एंड टाइम. नाउ we are defining the fact table. Same ही आएगा. Define cube cell snowflake is the name of the fact table. And these are the 4 dimensions: time, item, branch, location, right? And same measures are here: dollar sold, average sales, and the unit sold. Okay. Now what is the difference from the star schema? इससे क्या difference है? Look at defining the dimension item. तो ये item table है. item table को हमने extend किया है. We have added some extra attributes by extending this dimension. तो item की आएगा इसका primary key item का, item name, brand, type. Now for the item dimension we have extended this supplier key. We have added the supplier key and supplier type here. So supplier is the dimension attribute and it is again extended in the 2 attributes, supplier key and supplier type. So supplier and bracket में we are specifying the extended attributes. Similarly, we have the dimension location. अगर ये location table है, so we are extending the CT from this and CT will be again representing in the 3 keys, 3 values. तो location key as it is आएगा street, and for city we are adding the city key, province or state, and country. So like this we have to define the snowflake schema. We are not creating the extra defined dimension for this supplier and city, but we are just extending it in the available dimensions. Same way for the fact constellation. So what is the difference in this? We have to define 2 or more cubes because there are 2 or more fact tables. So first fact table हमारे example में था cells, जिसमें time, item, branch, location with all these measures are there. Secondly, we have to define the other cube, that is shipping. तो ये दूसरा फैक्ट टेबल है shipping, which is having the different time key, item key, shipper from location to location with the measures, dollar cost and unit shipped. Now these definitions are same as that we have seen previously in the star schema. Time, item, branch and location. Now these are seen used in the second fact table. So instead of defining it again, what we are doing here, define dimension time as time in cube cells. तो इसे हम कहाँ से फेच कर रहे हैं, फ्रॉम द सेल्स फैक्ट टेबल, सेल्स क्यूब. Similarly, the item, define dimension item as item in cube cells. Now in case of the dimension shipper, so define dimension shipper as shipper key, shipper name, and it is using this location dimension. तो जो हमने सेल्स फैक्ट टेबल में डिफाइन किया है वो हमें यूज करना है. सो वी आर राइटिंग हियर लोकेशन एज लोकेशन इन क्यूब सेल्स एंड शिपर टाइप. Again, there are two attributes or extended tables, dimension tables, that is from location and to locations. Obviously, they are extended from the location dimension created in the cells cube. So we are writing here as location in cube cells. So like this, we can create the fact constellation. We don't have to create the dimensions that are already created. If they are in sharing mode, we have to just give a reference to the already created dimensions from the data cube. So there are materialized views can be used to compute and store the aggregated data such as sum of cells. Okay, I have explained that views can be created on the base tables or on the tables. तो जो table आपने create किया है, we can create the virtual tables or read-only kind of tables we can create by using the views. Same way there is a special kind of views, that is the materialized views, that can be used and we can apply the different aggregate functions on it to have the computations. And we can have the summaries of the data available with this materialized views. They are also used to pre-compute the joins with or without aggregation. So we know that different joins can be required to fetch the data from multiple tables. So we can have the pre-computed joins results stored with or without aggregation function. If required, we can perform, or without aggregations we can do it. So this is for information that we have required in here the materialized concept. So efficient data cube computation. The data cube can be used as a lattice of cuboid. So we are seeing there is all at the apex, that is the 0 dimension. Then we can combine we have one dimension, after one dimension we have two-dimensional representation, after two-dimensional representation we have three, and like this it is forming the structure called as lattice. So the topmost or bottommost cuboid is the base. This is the base and this is called as apex. So there is how you can calculate the number of cuboids in the n-dimensional cube with L levels. So we can have the materialization of the data cube with this formula. Pi for I equal to 1 to n, L of I plus 1. So materialize every cuboid. If you are materializing every cuboid, we have full materialization, or we may have some partial materialization, or we may have no materialization. So we can select which cube to be materialized, or we don't want the materialization. So that can be decided based on the size, sharing and the access frequency of the data. Now in the previously we have seen how to create the schema. Like we have used define cube and define dimensions. Now how to perform the cube operations. So we have compute cube cells. Now like in SQL we can perform the different queries like operations on this cube. So we can write select. We have created the dimensions item CT year, and we have the sum of amount dimension. So we can apply the aggregate function sum of amount from cells. Cells is the cube we have defined. Then we have to write here cube by item CT and year. So this we have the cube of these three dimensions CT, item and year. So this is 0 dimension, 1 dimension, 2 dimension and 3 dimension. So we can perform the group by operation by using 3 dimensions. Similarly, we can have other like date, product, customer. Other dimensions can be added and we can have the cube of this 3 dimensions.